Hello, and welcome to a little video about exponential functions for decay and growth. I don't know why I read that backwards. Anyways, let's talk about exponential growth. First, I'm going to provide you with a formula, and then we're going to write down what each part of it means. All right, so here's the exponential growth formula. F of x equals p1 plus r to the power of x. Now, f of x is going to be your total. So that's going to be whatever we get for solving the problem. Next, we have p. P is called our principal, but this is our starting point, our starting value. Next, we have r. R is our rate, and this is our rate as percent rate as a decimal. And lastly, the x up top there is time. Whatever units of time are being used for this growth problem. Now, exponential decay has all the same pieces like f of x, the equals, the p, the 1, except for decay, instead of a plus, we've got a minus. For number 1, let's identify if these functions are growth or decay or neither. Now, for growth, we need a number larger than 1. For decay, a number smaller than 1. If we have neither of those things, then it's neither. All right? Letter A, we have a 3/5 inside the parentheses. Decay. 1B, we have 0.977. That's less than 1. That's decay. Letter C, we have an x inside the parentheses. That's neither, because x is a variable, not a number. For letter D, we have 1.0001. I said an extra 0, and I don't know why. One way or another, this is growth because it's bigger than 1. Letter E, we have a negative inside there, which is decay. We won't usually have a negative in there. That may have been a typo, but that's okay. Letter F, we have a number larger than 1, so that's growth. Letter G, we have 1.3. That's bigger than 1. Growth. Letter H, we have subtraction. 1 minus 0.9. That's going to be a number less than 1. That's decay. And lastly, letter I, 1 plus 0.19. That's going to be growth. Now, something that I found to be the most common mistake is this little part, and that's writing the growth or decay factor. And that's that part that's in the parentheses. Now, the most common mistake I see is not writing the percent correctly as a decimal. So let's practice that a little bit. Here we have a home that increases in value by 6% annually. So that means we need to do 1 plus our rate because it increases. Our rate is 6%. What is 6% as a decimal? Make sure to do 6 divided by 100, which gives us 0.06. So our growth factor is 1 plus 0.06, or we can even simplify it into 1.06. We have to do the same thing for letter B. We've got to take this 3.2 and turn it into a decimal. I divide it by 100, and what I get is 0.032. Now, the refrigerator is decreasing, so I'm subtracting my rate. You could leave it like this, or you can simplify it to 0.968. Let's continue and set up some more applicable problems. We won't solve these two, but we'll set them up. Number 3, a new car you bought for $25,000 decreases in value 15% each year. Okay? Didn't mean to make that pink. Let's change it. F of x equals. We start with $25,000. So that's the first thing we write down. That's our starting point. Next, our value decreases. That means we have a 1 minus. Our rate as a decimal is 0.15. And we raise it to the power of x because we don't know what we're solving for. A baseball card you bought for $5,000 increases in value 5% each year. All right, well, we started with 5,000. We are increasing in value, so 1 plus. Our 5%, our rate as a decimal is 0.05, and we raise it to the power of x. So 2 things that you guys may encounter in life, like buying new cars, and possibly if you're a collector, collecting some vintage items that might be worth a lot of money if you sell them later. Now let's do some actual calculations on some more applications. Number 4 is about ibuprofen. So exponents have a lot to do with medicine. And this is a very important thing, right? You don't want to overdose on medicine. Because if you take too much, you can cause yourself some really serious issues. So, an adult takes 600 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases by about 23%. How much ibuprofen is left after 5 hours? I might be wrong, but I believe that it's suggested that adults and children over 12 take ibuprofen only every 6 to 8 hours. And let's see why. So let's see how much is left in our body after 5 hours. So I'm going to set this up and then put it into my calculator. Our starting amount was 600. The ibuprofen is decreasing. So we have a 1 minus. 23% as a decimal is 0.23. And we have a time this time. We've got 5 hours. So we put that into our calculator. And what we get, I'm going to make this larger. Yeah. So I put it into my calculator, and what I get that after 5 hours, inside an adult's body will be 162.4 milligrams. So almost, I don't know, 2/3 of it gone? Or, right? Hold on. Now, I don't know. I didn't memorize this. I need to check it out. How much is remaining? Oh, okay. Yeah, so I said that right. I don't know why I doubted myself. Almost 2/3 is already digested by you, and you still have some left in your body. So that's why the safest thing to do is probably to wait that 6, maybe 7 hours before taking some more ibuprofen. Let's take a look at another problem that has to do with real life, like a savings account. Let's say you put in $1,000 into a savings account. Your bank offers you an interest rate of 1.2%. That means they're going to put in 1.2% of your money as long as you have it in there. And let's write 1.2% as a decimal, 0.012. And I want to see that if I don't touch this money at all, I just put in $1,000 and I step back for 10 years, how much money would you have in your account? Well, after 10 years, we would only have $1,126.69. That means we've only gained $126. Now, I'm hoping that if you are saving money, you're not just leaving $1,000 and not touching it. I'm assuming you're putting money in as time goes by. I like to put money into my bank account from every paycheck, and that's something that you should get into the habit of doing as well, even if it's a little bit. Now let's compare this bank account to another bank account with a very slight little difference, and we're going to see what difference does it actually make in the span of things. All right, so Carrie is considering depositing $1,000 into her account, just like we did in the previous problem. Now, Carrie's bank, unlike ours, well, it does have compound interest like ours does. as every bank does. But they offer 1.5%. Is it worth this little change if we are not going to put in any more money other than $1,000 and just leave it be? When we put this into our calculators, we get $1,160.54. So we made almost $40 more, less $34 more than the last savings account, which is not that significant. However, if we, for example, put in more money, then possibly Carrie would be winning in this bank account for number 6 rather than for number 5. If you have any questions, please make sure to ask me or anyone who's helping you with math. Otherwise, have a wonderful rest of your day. Bye!